Good morning, medias. Very good morning. So I'm continuing problems on addition theorem and probability medias. Yesterday we have done one problem where the probabilities of events are not equally likely. Probabilities of those events are proportional to some number on these medias. So that is what my dear problem little different from the previous problems. And all the problems are all the events are equally likely. I'm taking one more problem of same kind. Yes, now note on this problem idea. I'm sharing the screen. See that? This is the problem. Problem 130. Matter all of you note on the problem 130. A die is loaded such that the probability of each face turning up is directly proportional to the square of the number on the face. Find the probability of getting a prime number when the die is rolled. Actually, there is no conditional event here. Find the probability of getting a prime number when the die is rolled. That is a problem here. See that a die is loaded such that the probability of getting each face turning up is directly proportional to the square of the number on the face. Yes, my dear, it is not equal. Like Lala, you know, probably yes, my dear. Then find the probability of getting a prime number. Probability of getting what, my dear? Prime number. Yes. Okay, my dears. Come on. Now I'm going to the problem. See this, my dears. What is given is probability of getting a number on the face of the die when it is turned is directly proportional to the square of the number. Directly proportional. My dear, let us suppose k is the number. What is the turning about the probability of getting a number k is proportional to k square, where k values are what are the matter 1, 2, 3, 4, 5, 6. Because what is k? The number turning upon the face of the die. But what are the values of k, my dear? Numbers turning upon the die is what 1, 2, 3, 4, 5, 6. That is k, my dear. Probability of getting a number k on the face, upper face of the die, is proportional to square of the number. That means what probability of 1 is proportional to 1 square. Probability of 2 is proportional to 2 square. That is the meaning of that. So then what are that, my dear? This is given. So probability of k is equal to lambda k square, where lambda is a constant of proportionality. Lambda is a constant, directly right, or constant of proportionality. Yes, my dear, but then how can you find out lambda, my dear? For that, I'm using axiom of certainty. Probability of sample space is equal to 1. Since probability of sample space is equal to 1, then what is the sample space here, my dear? All of you know what is that? 1, 2, 3, 4, 5, 6. They are mutually exclusive and exhaustive. Therefore, sum of all the probabilities is equal to 1. Therefore, yes, that implies probability of getting 1 plus probability of getting 2 plus probability of getting 3 plus probability of getting 4 plus probability of getting 5 plus probability of getting 6 is equal to 1. But this is the important part of this problem, it is. I hope all of you understood. Somebody has doubt, please ask me. Yes, I don't think you have any problem here. Okay. Yes, my dear. Then what is probability of 1 according to this, my dear? Lambda into 1 square. Probability of 2, k is equal to 2. 2 into lambda into 2 square plus lambda into 3 square means probability of 3. That means k is equal to 3. Lambda into 3 square plus lambda into 4 square plus lambda into 5 square plus lambda into 6 square is equal to 1. So lambda is common, my dear. 1 square plus 2 square plus etc. plus 6 square is equal to 1. But this is sum of the space of natural numbers. You know the formula for that. What is the formula? N into n plus 1 into 2n plus 1 by 6 is equal to 1. N is 6 here. Substitute n, my dear. This is 6. 6 plus 1 is 7. 13 by 6 is equal to 1. 6 cancel. Lambda is equal to 1 by 91. Lambda is how much, my dear? 1 by 91. That's all. So therefore, what is probability of k? Now we represent probability of k is equal to lambda k square. Substitute lambda value, my dear, k square by 91. That is the probability. Yes, my dear, with the help of axiom of what you call certainty. But this is very important. Sample space is outcomes, possible outcomes from the random experiment ruling the die. Outcomes are 1, 2, 3, 4, 5. Sum of all the probabilities always equal to 1. That is the meaning of probability of S is equal to 1. Yes, but now I'm coming to the problem. What is the problem is? What is the problem of getting prime number? Actually, it is a problem of not any conditional event here. It is ordinary probability only because I have taken because of this axiom of certainty we didn't know in previous definitions. That's the reason I didn't take this problem that time. Okay. Now probability of getting a prime number. Now what is required probability is required probability is equal to what that measure? Probability of getting a prime number. Yes, my dear. What is the prime numbers here? All of you know 2, 3, and 5 only prime numbers. Yes, my dear. These are you have to take prime numbers from the outcomes. Outcomes are die. What are they made it 2, 3, and 4? That is what probability of getting 2 plus probability of getting 3 plus probability of getting 5. 2, 3, not 2, 3, 5, my dear. One is not a prime number. One is neither prime nor composite. Yes, my dear. Only even prime number is 2, remaining as. So now probability of 2, my dear. What is probability of 2? 2 square by 91. Probability of 3 is almost, my dear, 3 square by 91. And probability of 5 is what? 5 square by 91. That is 4 plus 9 plus 25 by 91, my dears. That is how much? 29, 38 by 91. That one, this is the required probability of this. Okay, my dear, I just have taken this problem because you have to understand this sentence, my dear. You have to read it properly. Probability of getting a number on the upper face of the die is directly proportional to square of the number. So this is very important, my dear. Okay, then and introducing the constant, proportional constant, probability of k is lambda k square, and you have to understand that k takes the values 1 to 6 because k is a number on the upper face of the die. What are the possible outcomes? 1, 2, 3, 6. That is also an important thing. After that, remaining we can do. Okay. Yes, my dears. Now I go to the next problem. Yes, my dear. Copy down. Next problem. This is the next problem, my dears. Sum number 131. This is also IP problem, my dears. 4-mark question. Sum number 131. Yes, what is sum number 131? All of you write down the problem. Write down, which is a IP problem also. A, B, C are 3 horses in a race. The probability of A to win the race is twice that of B, and probability of B is twice that of C. What are the probabilities of A, B, C to win the race? But it is completely different from previous problems, my dears. A, B, C are 3 horses in a race. Yes, my dear, what is the random experiment is what, my dear? Horses participating in the race. We got understood, my dears? Okay, that sample space is what are the ABC? They are exhaustive and mutually exclusive. Why exhaustive? Because 3 horses only participating. There is no other horse here. Okay. Why mutually exclusive? Maybe any one of them. If A or C is winning, B and C won't win. And B is winning, maybe A and C won't win, my dears. Okay. Probability A to win the race is twice that of B. What is given is 131 million. Given probability of A winning the race 2 times of probability of B. I think that is the first sentence. Probability of A to win the race is twice that of B. Probability of B is twice that of C. Probability of B is 2 times of probability of C. That is twice or thrice? Twice only. What are the probabilities of A, B, C to win the race? What is the probability of ABC to win the race, my dears? I think you understood. So here the sample space is what I can say, my dear. What are the events here? Sample space means what is the random space? It's race, my dear. And what are the outcomes is what is that, my dear? ABC. They are exhaustive and mutually exclusive. Clearly understood, my dears? So now sample space S is equal to what is that, my dear? A, B, C, three events. A means probably that horse A winning the race. What is B, my dear? Event B is the horse B is winning the race. What is C stands for? The horse C winning the race, my dears. Yes. Now, but then they're asking what is the probability of their respective probabilities. Probability is how much, and probability of B is how much, and even probability of C also they're asking, my dears. Again, we use what probability of S is equal to 1 only. Yes, since axioma set probability of S is equal to 1, and probability of S is nothing but probability of A plus probability of B plus probability of C is equal to 1. From this you get, because A, B, C are exhaustive and mutually exclusive. Listen to the words carefully. Exhaustive. These are the only three events. There is no other event. And that the thing is what mutually exclusive. Any one can happen, but it may be okay. Understood. They are not equally likely also, because probability of A is 2 times of that. Okay. Now we have to find out all of them. Is in probability of A, my dears, what I'm writing is probability of 2 times of probability of B. Yes. I'll keep probability of B as it is, my dear. In place of probability of C, I'm writing probability of B by 2. Because I converted it into only probability of B so that we can write a probability of B. Understood, my dear? I wrote this equation into only probability of B. Probability of B I replace it by what is it, my dear? 2 times of probability of B. I kept probability of B as it is. Probability of C is half of probability of B. I wrote that. Then you get probability of B. Simplify, my dear. How much you got? 4, 6, 7. 7 probability of B by 2 is equal to 1. Is it correct, my dear? 4 plus 2, 6 plus 1, 7. Correct. So probability of B is equal to what, my dear? 2 by 7. Probability that horse B is winning the race is 2 by 7. Then you can find out probability of A is 2 times of that. Yes, since probability of A is equal to 2 times of probability of B. 2 times of 2 by 7, that is 4 by 7. Yes, my dear, next probability of C. Where is probability of C are? Yes. Since probability of B is equal to 2 times of probability of C, that implies that probability of B, my dear, 2 by 7 is equal to 2 times of probability of C. Therefore, probability of C is equal to what? 1 by 7. That's all, my dear. Therefore, you got all the probabilities. Probability of A winning the race is how much, my dear? I got 4 by 7. Probability of B winning the race is 2 by 7. And probability of C winning the race is 1 by 7. Check, my dear, if you have it out, sum of the probabilities is 1. Check, my dear. 4 plus 2, 6, 6 plus 1, 7, 7 by 7, 1. Understood, my dears? That is a way. 4 more question, my dears. Right? Next. Exactly the same order problem, one more problem I'm taking. So, okay now. Still, my dear, 1 minute. I think it's okay. Okay, my dears. Same, exactly the same model. I'm taking one more problem. Come on, see that. Sum number 132, my dears. 4 candidates A, B, C, D applied for a post in a company. If A is twice as likely to be selected as B, and B and C are given about the same chances of being selected, while C is twice as likely as D, what are the chances that C will be selected? Question number 2. A will not be selected. I think 2 questions only. Okay. Yes, madam. 4 candidates A, B, C, D applied for a post in a company. Yes. A is twice as likely. A is twice as likely to be selected as B. We are doing sum number 132. Probability, what is given is 2 times of probability of B, my dears. I think first sentence, my dear, I'm reading again. The probability, yes. If A is twice as likely to be selected as B, may I see the sentence? They didn't use any word probability there. A is twice as likely. Likely means here, my dear, probability. Understood, my dear? That is the thing you have to understand. A is twice as likely to be selected as B. That means chances of A selecting for the post is two times as comparing with B. That is the meaning of that one. Next sentence is B and C are given about the same chances of being selected. B and C given as same chances of selection. It is given that same chances here made a probability only. Okay, and C is twice as likely as D, and probability of C is equal to 2 times of probability of D, my dear. Then what is the chance C will be selected? That is the next question, my dear. And A will not be selected. That is a question. You have to find out those things. I think you understood. Okay. Now going into the problem ideas. My dear, here what is the random experiment, my dear? Yes, what is that, my dear? Competition at, event of select. It is what, my dear, getting selected for the post in a particular company, or selection process, selecting a candidate for the particular post in a company. Yes, my dear, it's a random experiment here. Okay. But they are not all equally likely, my dears. It is given how many people are competing, my dears. Only 4 people are competing. S is what, my dear? A, B, C, D. Another question understood, my dear. Yes, A is twice as likely as B. That means probability of A selecting for the post is 2 times of that of B. That is the meaning of that. Already we gave the information, my dear. Then we use the condition from axiom of certainty, probability of S is equal to 1, and A, B, C, D are mutually exclusive and exhaustive events. There is no other person competing for the same post. Mutually exclusive, but if only one post, my dear. Yes, but they didn't mention clearly, but we have to understand that one. There is only one post. There is no chances of getting 2 people selected for that. Okay. Yes, madam. Then what follows? Probability of A plus probability of B plus probability of C plus probability of D is equal to 1, my dear. But suppose if they are not exhaustive, my dear, I cannot write 1. We can say less than or equal to 1, my dears. If they are not exhaustive, that means what they are the only one events of the sample space. We have to write it like this. Is equal to 1. If some other events, we have to less than equal to 1. Here understood, my dear, exhaustive. Those are the only events of the transaction, then we can write that way. That's all remaining thing we can do, my dears. What is probability of B? I'm replacing 2 times of probability of B, my dears. Okay. I'm keeping probability of B as it is. Probability of C is the same as probability of B. I'm replacing that also, my dear. Probability of B is PC by 2, my dear. Probability of C by 2, probability of D 1. In the next step, my dear, I'm replacing probability of C by probability of B. Meanwhile, it is how much, my dear? 4 times of probability of B. And probability of C, I'm replacing probability of B by 2 is equal to 1. Okay, my dear, how much I'm getting? 6, 7. 7 into probability of B by 2 is equal to 1. So probability of B is equal to what? 2 by 7. Okay, once probability of B came, then we can find out probability of A. Since probability of A is equal to 2 times of probability of B. 2 into 2 by 7, that is 4 by 7. Next, what I want, my dear, probability of C. Probability of C is also same. Probability of C is what, my dear? Probability of B, that is equal to 2 by 7. Now, probability of D is half of 2 by 7. Probability of D is equal to half of probability of C. That is half into 2 by 7. That is 1 by 7. Now, we got all of the probabilities. Probability for A getting selection for the post is how much I got, my dears? 4 by 7. Probability of B I got 2 by 7. Probability of C, how much you got, my dears? Same thing only. Probability of B, probability of C, same only. Probability of D is equal to 1 by 7. These are the probabilities. Let us check, my dear, sum of all these probabilities is equal to 1. Something wrong? Yeah, my dear. 4 plus 2, 6, 6 plus 8, 9 by 7. Yeah, wrong. Something I've done wrong, my dear. Some of the probabilities must be equal to 1. Somewhere I've done mistake. Yeah, two times of probability of C, correct. Probability of D is yes. Yes, my dear. I wrote mistake here, my dear. This is what, my dear? 8, 9. 9 by 9, 9b by 2. So this is what, my dear? 9. So this is also 9, this is also 9. 2 by 9, 1 by 9. 9, 9, 9. Yes, but add them, sum of the products 4 plus 2, 6, 6 plus 2, 8, 8 plus 1, 9, 9 by 9, 1. Right. But actually, we have to answer the question, but according to us, they're asking probability of C and probability of A not selecting. First question is, I think, probability of C, my dear. Probability of C is what? 2 by 9. Second one is probability of A non-selection. Probability of A bar, that is 1 minus probability of A. That is 1 minus probability of A is what? 4 by 9. That is what, my dear? 5 by 9. That's all. Clearly understood, my dears? Have done same model, two problems, my dear, for understanding. I hope you understood. Now I'll go to the next problem. Come on, right down. Next problem is, my dears, yes, my dear, 133. My dear, this is also IP problem. 133. 133. All of you note on the problem also. If the probabilities of three mutually exclusive events are respectively given, probabilities of three mutually exclusive events are 1 plus 3p by 2, 1 plus 3p by 3, 3 or 2 now. And 1 minus p by 4 and 1 minus 2p by 2, 1 minus 2p by 2. And what we're asking is show that or prove that 1 by p is, sorry, 1 by 3 is less than p less than 2. What is IP problem, yes? So it is actually bold ITJ problem. It is somewhere very bold ITJ problem. Now they made it a what is that IT problem? Very bold IT problem. Okay. Yes, my dear, I think we all have understood, my dear. The probability of 1 minute. Yes, my dears. Okay, 1 minute. Okay. Yes, my dears, come on, see that. See that, my dears, what is given is given probabilities of three mutually exclusive events on this, then prove that P lie between 1 by 3 and 1 by 2. These are the, let the three mutually exclusive A and B. Let three mutually I think we need more space, maybe I'm letting it to this side. Let the three mutually exclusive events be A, B, C. And let probability of first event is 1 plus 3p by 3, my dears. And probability of second event, probability of b is equal to 1 minus p by 4. And the probability of c is equal to, my dears, 1 minus 2p by 2. Yes, my dears. Actually, these are all the probabilities of three events. But they are asking about the constant p. The constant p must lie between 1 by 3 and 1 by 2. That we have to prove, my dears. Okay. Yes, my dear. What is your opinion, my dear? I think most of all of you got idea. All of you know that probability of any event lie between 0 to 1. Understood, my dears? Probability of any event lie between 0 to 1. All of you know that. Since we have 0 is less than probability of E is less than equal to 1 for all E subsequent. Yes, all of you know this. My dear. Yes, all of you know this. Okay, now I'm using this one. So I'm writing since 0 is less than probability of A is less than equal to 1 implies 0 is less than 1 plus 3p by 3 less than or equal to 1. From this you get one inequality, my dear. Similarly, probability of B also lie between 0 to 1. Probabilities of lies between all 0 to 1. Then you have to take the common of all the three results. Am I right? Go ahead, my dears. Yes, now I want to get the p values. I'm trying to eliminate these three, multiplying by 3. Like better, I'll write this side because I have to manage the equations. I want more space, my dear. 0 is less than equal to 1 plus 3p by 3 is less than equal to 1. Multiplying by 3, 0 is less than 1 plus 3p less than equal to 3. Subtracting 1 because I want to get rid of this. 0 minus 1 less than equal to 3p less than equal to 2 minus, sorry, that is 2. Subtracting 1, yeah, directly I'll write what is there. Minus 1, 3p is less than equal to 2. Dividing by 3. Minus 1 by 3 less than p less than equal to 2. This is the first one we got. By taking probability of A lie between 0 to 1. Now I'm taking probability of B, maybe write down. Since 0 is less than probability of B is also less than equal to 1. Guess what this one, my dear? 0 is less than 1 minus p by 4 less than equal to 1. Now we want to get the p values. Now I'm trying to eliminate 4 and 1. By multiplying by 4, 0 is less than 1 minus p is less than equal to 4. Subtracting 1, minus 1 is less than, minus p is less than equal to 3. Both visible now. Yes, my dear, multiplying by minus. You will get minus 3 less than equal to p less than equal to 1. When you multiply, my dear, minus, you have to start from RHS, my dear. Minus 3 less than or equal to p less than or equal to 1. I think I hope all of you know this, my dears. Right. Otherwise, you try yourself. So this is what my second one. Now, similarly, since 0 is less than, probability of C is less than equal to 1. Yes, probability this one, my dear. 0 less than or equal to 1 minus 2p by 2 less than equal to 1. Multiplying by 2. 0 is less than 1 minus 2p is less than equal to 2. Subtracting 1. Minus 1 is less than, minus 2p is less than equal to 1. Multiplying by minus. When you multiply minus, you have to write from other side. Minus 1 less than equal to minus and minus 2p to p less than equal to minus 1 into minus 1 plus 1. Dividing by 2. Dividing by 2, my dear. Minus 1 by 2 less than t less than equal to 1 by 2. Okay. This is the third one. Okay. But then we is asking p value. Then what I'll do, I'll take the common of these three. But p value first equation p of a like between 0 to 1 for any value of p from minus 1 by 2 by 3. That's the meaning of this, my dears. P value range is minus 1 by 2 by 3 in order to satisfy 1 plus p by 3 is like between 0 to 1. Yes, my dear. 1 minus p by 4 lie between 0 to 1 as long as p values are minus 3 to 1. And similarly, 1 minus 2p by 2 lie between 0 to 1 as long as p values are minus half to plus half. But all the three equations must satisfy simultaneously, means you have to take the common of all the three. Because my dear, these three must be probabilities of three events at the same time. That means what we have to take common of all the three medias. Then find out medias. For finding common of intervals, maybe better go for the diagram. First interval minus 1 by 3, 2 by 3. I'm thinking thick line. Minus 1 by 3, and this is 2 by 3 media. Thick line I'm drawing it. This is the thick line. Okay. Next interval is what varies that media minus 3 to 1. Minus 3 is somewhere here far away. To 1 is also here. I'm writing that as a curved line. Okay. Next one is what this is minus half to plus half. Minus half means what, my dear? Minus 1 by 3 is 0.33 here. Minus half is minus 0.5. Minus 0.5 is here. This is minus half. Half is 2 by 3 is 0.6, my dear. Half is somewhere. 2 by 3 0.6. Half is somewhere here. This is half. That interval I am writing this way. Now, what is the common code of these medias? For all the three, thick line and curved line and the slashes, minus 1 by 3 to 1 by 2. What I got is minus 1 by 3 less than 50 less than 1 by 2. Understood, my days? Yes, now all of you got doubts, sir. Actually, answer to 1 by 3 is then we got minus 1 by 3. Some of you have got also, okay, maybe answer is wrong. Maybe I have done mistake. That is not the correct medias. What we have done is correct medias, but actually we didn't consider one thing. What is that media? Yes, sum of all the probabilities. That also have to consider media. Yes, what is that? If all of them are exhaustive events, media, we have the condition probability of A plus probability of B plus probability of C is equal to 1. In the previous problems we are doing yes, we didn't use this condition. Yes, when the sum of all the probabilities is equal to 1, provided A, B, C are exhaustive events. Are they exhaustive media? They didn't give their exhaustive, they gave only mutually exclusive. They didn't mention anywhere they are what are the media exhaustive. That's the reason media I cannot take it as is equal to 1. It is less than or equal to 1. Clean understood media? That is the reason I am doing this problem. Otherwise I won't do this. Clean understood? P of A plus P of B plus P of C less than or equal to 1. When can a rate media is equal to 1 media? The case is they gave the word exhaustive events. When there is a word in the problem media, A, B, C are exhaustive events, directly write sum of the probabilities is equal to 1. But they didn't give exhaustive events. That is reason I have to go with what? Probability of A plus probability of B plus probability of C is less than or equal to 1. Clearly understood, my dears? From that, we get another inequality. Then you have to take the common of all those 4 inequalities, you'll get the final answer. Clear? Right. Right on. Yes, my dears, come on, see that. I'm writing next one. Since probability of A plus probability of B plus probability of C is less than or equal to 1. Yes, madam, go ahead, get the answer. Probability of A is what? 1 plus 3p by 3 plus 1 minus p by 4. 1 minus p by 4. 1 minus 2p by 2 less than or equal to 1. LCM is obviously what is it? 12. Am I right? 12 only medium. 4 plus 12p. 3 minus 3p plus 6 minus 12p less than or equal to 1. This 12p minus 12p cancel. 13 minus 3p is less than or equal to 12. Class 1 multiplication area. Now sending 13 to that side, minus 3p is less than or equal to minus 1. Multiplying the minus sign, 3p is greater than or equal to 1 by 3. So sorry, 3p is greater than or equal to 1. When you multiply minus n media, I think all of you know, remember that one media. Order changes. Less than becomes greater than becomes less than by multiplying by minus sign. Okay, therefore p is greater than or equal to 1 by 3. This is the fourth inequality we got. Now take the common of all of them. Come on, quick. Now I'm writing all the intervals here. One diagram I'm making. Yes, my first interval is minus 1 by 3 to 2 by 3. Minus 1 by 3 to 1, 2 by 3. Na? Yes, my dears. For that interval method, I'm using thick line. Better method always diagram representation is better. You won't get any mistake. Careful. Next one is minus 3 to 1. 1 is here, minus 3 somewhere here. That one I'm representing with curved line. Okay. Next interval is what? Minus half to plus 1 by 2. Half is here, minus half here. 1 by 2. 2 by 3 is 0.6 here. 1 by 2 is less than this. This is 1 by 2. For that matter, I'm using slashes so that you can understand better. Okay, minus 1 by 2 this. Last portion 1 greater than 1 by 3. 1 by 3 is what? How much by here? Somewhere here. This is 1 by 3 somewhere. Greater than 1 by 3 means up to infinity. That is line. Now, what is the common part by the thick line, curved line, slashes, and this line? 1 by 3 to how much appears? 1 by 2. Therefore, 1 by 3 is less than P is less than 1 by 2. Then you will get 4 marks, my dears. Okay? All of you understood, my dears? This problem based upon what is the probability of any event lie between 0 and 1. That is the first thing. Second important thing is, my dear, sum of the probabilities of all the 3 events, probability of A plus probability of B, probability of C is not 1, less than or equal to 1, because they are not necessarily exhaustive events. If it is given exhaustive, would have taken is equal to 1. So this is the caution. It's clearly understood. And one more caution is how to take the intervals with the help of a diagram. Even in board examination mathematics, please make this diagram. Yes, you won't get any wrong answer. I hope all have understood. Yes, right on. Come to the next problem, yes. Write down the solution. Yes, now coming to the next problem. Yes, my dears. Yes, my dear, ABC are 3 newspapers published from a city. 20% of the population read A, 60%, 16% read B, 14% read C, 8% read both A and B, 5% read both A and C, 4% read both B and C, and 2% read all the 3. Find the percentage of population who read at least one newspaper. My dear, this is actually, my dear, it's a problem from set theory. Yes, my dear, of course, because why I have taken the problem is because it is asked in IP 2 years, 2018, 2017 also. That's the reason I have taken the problem here. But we can solve it. Yes. Come to the next problem, yes, see that. So directly you can solve it by the help of Venn diagram. No need to explain too much on this media. 3 newspapers are there. Question number 134, my dears. Okay. Better Venn diagram. We do both the ways. Okay. Just made it accordingly. MSET and JEE means we can use directly. Yes, my dear. See that question, my dear. ABC are 3 papers published from a city. 20% of 20% of the population read A, and this is A, my dear. 20% read A, and 16% read B. This is 16%. Don't write that 16% but B. The 16% indicates the whole circle. That's the meaning that my dears. Don't write inside 20% A. Write outside 20%, my dears. Next, 14% read C. This is C, my dear. This is 14% of the population. Both A and B, 8% read both A and B. A and B means the whole thing, but this convex lens 18%, 8%. But actually, before I'm going to the last one, I did 2% read all the three. 2% all the three means this triangular shape, but this is all the three. This is 2%. I wrote the last sentence, my dear. 2%. Now I'm coming back to the first. 8% read both. 8% read both A and B. 8% read both A. This whole is 8%. Because this is 2, my dear, I'm writing 6% remaining for. My dear, I think please, all of you please notice that one, my dears. 8% read both A and B. Because already 2% reading both all the three, I wrote them. So remaining 6% is what only A and B. What is the meaning of 6% is the number of percentage of people who reads only A and B, not C. Only A and B means not C. That is what 6%. Next, my dear, 5% read both A and C. A and C, this is called 5%. 5%. Already 2% is here, right? 3% A. 3 plus 2, 5. 5% read both A and C. What is 3%, my dear? Only A and C. When they use the word only A and C means they are not reading paper B. They are reading A and C, not B. Yes, my dear. Next, 4% read both B and C. 4% total. This is 4%. Now this is 2%. Now, what is the question is? Find the percentage of population who read both the newspaper, at least one newspaper. Find the percentage of population who read at least one newspaper. Yes, my dear. Now I'm stopped sharing, my dears. I think all of you noted the problem. At least one newspaper. Percentage population. At least one newspaper. At least one newspaper means what, my dear? You have to find out N of A union B union C. A union B union C indicates what means at least one paper. A union B union C means either A or B or C or any two or all the three. That is the meaning of N of A union B. So find out. N of A union B C from substitute made a directly get answer. Before that I am writing what is given is N of A is given 20%. Yes, my dear, N of B is given 16%. Directly you can write the answer actually. Yes, my dear, what is the meaning of, because it is only for objective point of view writing, my dear. At least one of them. Yes, my dear, directly write the answer here. N of A plus N of B plus N of C minus N of A intersection B minus N of B intersection C minus N of C intersection A plus N of A intersection B intersection C. My dears, N of A is how much? 20%. Plus N of B is 16%. Plus N of C 14%. Yes, my dear, minus N of A intersection B 6 plus 2 8%. Minus B intersection C 4%. 2% plus 2%, that is 4%. Minus N of A intersection C 5%. Plus N of A intersection is 2%. How much, my dear? This is 36 and 50, 50 plus 2, 52. Am I right? 36 plus 36 plus 14, 50 made it 52, 17. Am I right? Yeah, 12 plus 17. When you subtract, how much you're getting, my dear? 12 minus 7, that is 5, 4, 35%. That's my dear. So, number of percentage of population who are reading at least one newspaper is 35%. That much easy it is. Okay, that is the way. But actually, because this is given in board examination media, I don't think if you answer like this, they won't give the marks media. We use the probability way concept. Okay, right on. So, my dear, this is board pattern. I'm writing the solution like this, my dears. Uh, Given A, B, C be the events of people the reading newspapers A, B, C respectively. But just I'm introducing the events because we want to answer this question with the help of what is the probabilities media. I'm describing what is the data. I didn't say even it with it. I've taken what is that A stands for event that for people reading the newspaper A, and B stands for people reading newspaper B. C stands for the event that people reading newspaper C. So I introduced them it is. Then immediately, yes, my dear, I'm writing the given information. Yes, what is given information is probability of A is for what my dear 20%, that is 20 by 100. Yes, madam, we can simplify and leave it otherwise. I'm leaving as it is made for simplification future. Probability of use means probability that a person is randomly selected to read the newspaper is 20%. 20% is what my dear. You know the meaning, 20% out of 100 people, 20 people. That is probability only. Because basic people have taken what is that many 100 and of yes, that is probability is 20. That is probability only 20% is we have to put 20 by 100. Clear understood, my dears? Probability of B. Probability that you randomly select a person reading the newspaper B. And probability of C. How much, my dear? 14 by 100. I think you understood, my dears. Next, probability of A intersection B. 8 by 100. This is the intersection total 6 plus 2 8. Next probability of B intersection C 4 by 100. Probability of C intersection A 5 by 100. I think you all have understood the meaning. What is the meaning of probability of A intersection B? Probability that a randomly selected person reading both the newspapers A and B 8 by 100 8%, 6 plus 2 8%. This is A and B means. Only 6% is only A and B. That means what will be the probability of A intersection B intersection C complement? That is 6%. Please be aware of this. Only A and B. They are reading only A and B, not C. That is what 6%. 6 plus 2 is what? A and B. That means some people are not reading C, some people are reading C also included in that. Okay? I think you understood, my dears. Next. And the probability of A intersection B intersection C is what? 2%, that is 2 by 100. Now, what is the question is probability of percentage of people are made. First, I'll go for probability. The probability of that can read at least one of newspapers A, B, C. Let us see the sentence made. Probability that a person randomly selected person. I have to write actually a person randomly selected can read at least one newspaper at least one newspaper of newspapers A, B, and C. Yes, my dear. Probably that a randomly selected person can read at least one of the newspapers ABC, A, B, and C. that is equal to probability of A union C. So what is the probability, my dear? All of you know probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of B intersection C minus probability of C intersection A plus probability of A intersection C. Substitute the values, my dear. Probability of A is how much? 20 by 100 plus probability of B 16 by 100. That's the reason, my dear. To simplification purpose, I didn't simplify that. I left as it is. But this is what, my dear? 14 by 100 minus 8 by 100 minus 5 by 100 minus 2 by 100 plus this is how much, my dear? 4 by 100. 4 by 100 and this is 5 by 100 plus 2 by 100. That is coming out 35 by 100. But this is what, my dear? Probability of A union B union C is equal to 35 by 100. This is probability that a randomly selected person from the population can read at least one of the papers ABC. This is probability, not percentage. If you want to get the percentage, you have to multiply the probability by 100. See, please notice the difference here. This is probability that a randomly selected person from the city can read at least one of the papers is 35 by 100. But we want percentage of the population. Okay, now we have to multiply the probability by 100. Yes, that is the last sentence. Therefore, percentage of population. Yes. Reading at least one of. Reading at least one of newspapers A, B, C is equal to probability of A intersection B intersection C into 100. Probability to 100 minutes. Please, all of you, please notice this one. We didn't write this formula anywhere, but this is the meaning of it. Probability of intersection B C is 135 by 100 into 100. That is 35%. Yes, my dear, that's all, my dear. 35% of population reading this is the way maybe they're expecting in IP examination, my dears. Okay. I hope all have understood. Now I'm going to the next problem. Yes, my dear. Next problem is this. So it's 135, my dears. Next question is 135. This is more than one option correct, my dears. See the question. All have read down the question that we find. More than one option correct. Okay. Now coming to sum number 135, my dear. If A and B any two events such that probability of A is 0.5, probability of B is 2 by 3. 135%, my dears. Probability of A is 0.5. 0.5 means how much? 1 by 2. And probability of B is equal to 2 by 3. It is given, my dears. Then which of the following statements is or true? He gave some 4 statements, my dears. Of course, and you know the answer from that this one also. Yes, my dear. Now first one is he's talking about the probability of union B. That's all. This is given information here. First option, my dear, what is probability of A union B, my dears. E is greater than or equal to, it is given 2 by 3. But because this is more than one option, my dear, better I'll check one by one. So stop sharing now. Probability of union B is greater than 2. Yes, my dear, it said A and B, my dear. Let us suppose this is A. They didn't give A and B as mutually exclusive. If they give mutually exclusive, my dear, you should not draw the diagram. You have to draw them. A and B, because A and B do not have any common if it is given mutually exclusive. it is not given. So they can have a common part. So this is the case method. Okay. So now in this case, I can take it as this is A and this is B. When you see that probability of A and B means what? This plus this. Am I right? Probability of A and this A plus this convex lens, or the B plus this convex lens. That is U and B. Obviously, the probability of A and B is greater than probability of B. Probability of B is 2/3. See that? Yes. Because this is correct. Since probability of A and B definitely greater than or equal to probability of B, or probability of A, or probability of A intersection B, my dear. Obviously, we know that probability of A and B is greater than A, or greater than B, or greater than A intersection B also. And probability of B is 2/3. So, therefore, obviously understood, my dear, probability of, all of you understood it. Probability of A and B is greater than probability of B, or probability of A, all the three. So, therefore, probability of A union B is greater than or equal to 2/3 times B. Yes, my dear. Now coming to the second option, my dears. What is the second option given? Yes, my dear. B option is this. B, my dear. They are asking 1/6 is less than or equal to probability of A intersection B is less than or equal to 1/2. They are asking us to check this one, my dears. 1/6 probability of A intersection will lie between probability of A intersection will lie between 1/6 and 1/2. But this is what inequality, no doubt, is not asking exact value. But if you see very carefully, what they gave is probability of A and probability of B is given. Probability of A is given, probability of B is also given. And is also information about probability of A intersection B. You know this formula is probability of A and B is equal to probability of A plus probability of B minus probability of A intersection B. We have this relation, addition theorem on probability values. And that too is asking the range of A intersection B. That's the reason how I am starting this problem. You know, my dear. Probability of, I start with probability of union B. Probability of union B definitely lie between, yes, but a lot of you know probability of union B, probability of that, we know that. Why I'm taking both inequalities, my dear? Because A intersection B has lower boundary and upper boundary also. That's the reason I'm starting with this. Okay. Yes. You know, yes. Now I'm writing the formula. Probability of unity, probability of A plus probability of B minus probability of A intersection B is less than or equal to 1. I'm substituting the values for probability of A and probability of B. What are they? 1/2 and 2/3. Write down. 1/2 plus 2/3 minus probability of A intersection B less than or equal to 1. By adding them, how much you're getting here? 7/6. Am I right? 1 is less than or equal to 3 plus 4, 7/6 minus probability of A intersection B is less than equal to 1. But we need the range of A intersection. That's the reason I want to eliminate 7/6. That is, I'm subtracting 7/6. I'm writing the other part here. Yes, my dear, 0 minus 7/6 is less than or equal to minus probability of A intersection B less than or equal to 1 minus 7/6. This is minus 7/6 is less than or equal to minus probability of A intersection B is less than or equal to, this is how much, my dear? Yes, my dear, what is that? Minus 1/6. Yes. Okay, man, because I need the what you call the positive side, multiplying by minus sign. Okay. Multiplying by minus sign, what will happen when you multiply minus sign? I told you I'll write from other side. Multiplying by minus here, 1/6 less than or equal to probability of intersection B less than or equal to 7/6. So lower boundary of this is 1/6, my dear. But upper boundary got 7/6 here. But in the answer it is given 1/2. What is wrong I've done? I didn't do anything wrong. We know that my dear, probability of A and B lie between what is that 0 and 1. Yes, my dear, this is correct. But actually 7/6 is a value greater than 1, my dears. So actually instead of that I can write this as 1. Less than or equal to 1 I can write. because 7 by 6 probability cannot be more than 1. So up to 6, I can write 1 by 6 is less than equal to probability of A intersection B is less than equal to -1. But answer is given 1 by 2, my dear. So what answer is wrong, my dear? I cannot say. Problem is what, my dear? We missed one thing. This is correct only, my dear. No doubt in that. But already from the option 1, probability of A and B is greater than 2 by 3. We didn't use that one. That's why I'm getting another result. But already we know that when probability of A and B greater than equal to how much, my dear? 2 by 3. So use that one, my dear. So lower boundary is what, my dear? I start with 2 by 3. See what will happen. And this is also 2 by 3. Understood, my dear? This is, I'll make it as 2 by 3, 2 by 3. This is what, my dear? 2 by 3. Okay, then I simplify this one, how much I get? 6 is LCM. 4 minus 3 minus 3 by 6. That is minus 1 by 2. Yes, multiplying by minus n, 1 by 6 is less than equal to probability of A intersection B is less than or equal to plus. This is 1 by 2, 3 by 6 is 1 by 2. We got it. I think all of understood, my dear. What the thing is, I need to use this information. At 1 minute, exactly go. Let me do this. Okay. So that is the reason, my dear, option B is correct. Now next time go to the next option. What is the next option, my dear? Option C. Option C, my dear, is probability of A intersection B complement is less than or equal to 1 by 3. Okay, my dears, see that option, my dears. You have to check the option C, probability of A intersection B is less than or equal to 1 by 3. Yes, my dear, what is the information available with us? Okay, my dear, already, my dear, one of probability of A intersection B complement is probability of A minus probability of A intersection B. My dear, all of you this formula. Probability of A intersection becomes the occurrence of A only, not B. That is probability of A minus probability of A intersection B. Okay. But to get this one, but already we know probability of A intersection B information. Probability, since we know that 1 by 6 is less than equal to probability of A intersection B is less than equal to 1 by 2 is there. But I'm using that only because we need this. Multiplying by minus because we need this. Because I want this, I am going to create this. Probability of A minus probability of intersection B from this. Because we need minus and multiplying by minus. When I multiply minus from other side. Minus 1 by 2 less than equal to minus probability of A intersection B equal to minus 1 by 6. Okay. Now, because I want P of A, I'm adding P of E. P of A minus 1 by 2 less than equal to P of A minus probability of intersection B less than equal to P of A minus 1 by 6. Now write P of A value, made it. All of you know P of A value how much? 1 by 2. Substitute that value, my dear. That is 1 by 2. 1 by 2 minus 1 by 2 less than equal to. I'm writing not P of A here. P of, I'm writing capital, don't write here because I'm writing this as P of A intersection B complement less than equal to 1 by 2 minus 1 by 6. Yes, so this is 0 is less than equal to probability of A intersection B is less than or equal to. Simplify this one here. How much? 1 by 2, 1 by 6 is 3 is LCM. Sorry, 6 is LCM. 3 minus 1, 2. Yes, we got the answer. 0 is less than equal to probability of A intersection B complement is less than equal to 1 by 3. Yes, my dear, understood now. Yes, I am using that. What is that, my dear? To handle this one, you should know this formula first. Probability of A intersection B complement is probability of A minus probability of A intersection B. You should know that. Okay. Yes, my dear, then remaining part is creating that. Option B also same thing, we can do it. Okay. Fine, my dears. Now I'm going to the next problem. Yes, yes, my dear, this is the next problem. Yes, ma'am. 136, my dears. All of you please note down some number of 36. Okay, come and see this, my dear. For 3 events ABC, probability of exactly one of AB occurs is equal to probability of exactly one of BC occurs is equal to probability of exactly one of C occurs is equal to 1 by 4.